All right. Welcome to Full Momentum and HEC-RAS podcast. I'm your host, Ben Cary, and joining me here today, as always, is Chris Goodell. And Chris, we also are fortunate to have some really special guests joining us today. Again, we've been lucky to have a couple of folks from HEC on previous episodes, and we got two more joining us today. So I'll turn it over to you to introduce our guests for today.
Yeah, thanks, Ben, and welcome everyone to another episode of Full Momentum. And we've got Cameron Ackerman and Anton Rotter-Sieren from HEC, and super excited to have both of these guys here today to tell you a little bit about some of the new RASMapper capabilities in version 6.0, and also a really cool demonstration of the new 3D viewer. Which is taking the HEC-RAS world by storm. Everybody's super excited about this. I don't think Anton really knows the impact his work is having. So we're excited to see that, and excited to see what Cam has to share with us. But anyway, so welcome, guys. Thanks for joining us.
Thanks for having us. My goal for today is to see if we can get a blooper on the vodcast reel. That's my goal for the day.
That's not going to be a heavy lift right there.
It'll probably come from me. I know it.
Well, Gary had plenty of bloopers on the last one, but he made us cut all of them so the world wouldn't see.
Yeah, that's right. That's right. And anyway, it's really cool to have you guys here. A lot of you probably don't know that I got the opportunity to work next to Cam at HEC for a couple years, way back in the 2001-2003 timeframe. And for much of that time, I think we sat next to each other, right? And things would tend to kind of fly over the cubicle walls, and other hijinks like that would occur.
Those were the good days where you didn't have to worry about since we had kind of our own little office in the annex and our own little office out there, we didn't really have to worry about what happened. We were okay with throwing things over the cubicle and all sorts of hijinks.
Yeah. So that was back when what happened at HEC stayed at HEC kind of thing.
Exactly.
That's right. We won't tell all the stories, but we had a good time. I remember, for a part of my time there, we actually got moved into, I think, what was the IT room. And so it had all that soundproofing tile all over. And that made for opportunities for some kind of impromptu games of darts, where we would throw darts against the wall and just have fun with that.
Yeah, that was
blast Metallica.
We did not blast Metallica. We had other things we were listening to, which I'll let Chris get to. But that was great because that was the summer HEC decided to remodel, and the air conditioner in that particular part of the building was excellent because we had to keep the servers cool. And so we moved in there, and it was a little bit noisy with the servers, but we weren't. It can get to be 105 in Davis. We were never hot that summer, so that was nice.
Yeah, for those of you who haven't experienced Davis, California, and actually much of the Sacramento Valley, it gets pretty hot all summer, and it stays that way. And so it was nice to have that AC room. But one of the things that we like to do on Fridays was to pull out some old school rap and pick a new rap song each time and let it blare through there as we worked on HEC-RAS.
Had to drown out the servers somehow, and nobody ever came in there because you and I and I think Mark Jensen had a little stint in there with us. So
yeah, I think Steve was in there too. I think all four of us were in there at one point anyway. So
that's awesome. So obviously it's been well established, Chris, that you had the opportunity to work with Cam and Gary at HEC back in the day, and Cam and Gary both been super influential on the new 6.0 version of HEC-RAS, which is what we're going to be touching on today. But I don't think as many folks know of Anton, so I'd like to give Anton an opportunity just to kind of introduce himself and let folks know kind of your role in the new HEC-RAS version, kind of what you did with that.
Okay. So hi, my name's Anton Rotter-Sieren. I'm the newest team member for HEC-RAS, and I've been at HEC for 3 years, and I'm a UC Davis alumni, and I'm currently a master's student at Georgia Tech. Although it's an online master's, so I get to stay home and I don't have to go to Atlanta to.
Nice.
Then,
and what? Yeah, go ahead. I was going to ask
Yeah.
what your role was with HEC.
yeah, the first thing they put me on when I got here, they were telling me like, oh, you're going to be on the RAS team. I was like, what's RAS? I don't even know what that is. And first they started me with nothing really RAS specific. They had one of the improvements in 6.0 is our ability to render many points in RASMapper. And that's all thanks to the first thing they made me work on, which was a quad tree data structure. And so while a lot of people probably haven't noticed that because it's such a subtle change, like that was the first thing I worked on. And then they made me start digging into the RASMapper code, and I started fixing bugs and adding new features. And then earlier, Gary always wanted to have a 3D viewer for RAS, but all the other team members were too expensive to waste a lot of hours on making it. And I was a new member, and I was cheap labor. And so sunk a lot of hours on the 3D viewer. And at first it was rough. It could only like do like three, like a couple feet in front of you, like in high definition, and the water didn't animate, and it's come a long way, but there's still a lot of work left for it. And I'll talk about future plans for it after I give my demo.
Yeah, that's awesome. Cool. I know it's been something that I've really enjoyed watching, both other demo videos and just kind of exploring myself. It's definitely something that obviously anytime there's something totally new to HEC-RAS, it's really exciting, and that 3D viewer is really, really cool. Had you worked on anything like that previously in other jobs or classes where you were basically designing a standalone feature for a software program?
No. You know who helped me a lot was Alex Kennedy, because in his master program, he did take a couple of computer graphics classes. So he got me going in the beginning with setting up DirectX and getting all the shaders working and all that. But after that, it was just a lot of research and trying things out and converting from different languages, because not everything's in C# or VB.NET. Some of it was in Java or Python. So, yeah.
Very cool. So your
Awesome.
education is computer science, right, at UC Davis?
Yeah, that's right.
And you're continuing that at Georgia Tech.
Yeah.
So a lot of people don't know this, but it used to be on the HEC-RAS team, it was just a bunch of hydraulic engineers, me and Cam and Gary, Mark, and Steve, who just learned how to code basically. And a while back, I think maybe 15 years ago, you started bringing on computer science experts onto the team, right, Cam? I think it was about that time. And we saw a really significant improvement in the graphics, things that you see in RASMapper, like the particle tracing and the image displays, and now the 3D viewer. All those things are a result of bringing on computer science experts versus trying to train hydraulic engineers to be coders.
Right. Right. Yeah. It's we have a nice, being right next to UC Davis. It gives us the ability to bring on students to work during the summer and do some, work on some ideas that we've got and kind of do a rough draft, an alpha version or a beta version, and then take it further with the next student that's able to come along. So, but yeah, once Alex Kennedy came on board, the the tools that we had just exploded because we had a whole dedicated person, and it was a dedicated programmer, which is really, really, really nice.
Yeah,
one of the perks of being a dedicated programmer is I have to answer very few emails.
Yeah, but now you probably know as much hydraulic modeling or hydraulic engineering as many hydraulic engineers out there, just by absorbing it.
He wishes.
Yeah, I'll get there. I'm still not quite there.
You'll get there, yeah. So
Cam and Gary both probably keep him humble.
So those of you who've watched our podcast in the past know that Ben and I like to talk a little bit about beer and craft brews especially. And Cam has some interesting news. What happened recently, Cam?
I won the lottery. I won the Russian River Brewing lottery. Which for those of you around the country who are beer aficionados and enjoy a cold one after work, you're probably familiar with Pliny the Younger. Every February, Pliny the Younger is released by Russian River. We're fortunate. We live within about an hour of the brewery, so the local watering holes in Davis will have a secret day, or maybe it won't be so secret, where if you know to go stand in line that day, you can get in and have a little sample of this. It's a triple IPA. It's excellent. They only do a limited batch once a year. And this year, because of COVID, they did an online sales where they would ship to residents in California. So nice. From what I know, it was about 6,000 12 packs, which were mixed. So you only got 4 bottles in a 12 pack, and then they put in other beer. But 6,000 12 packs, and there was when it went live, there was over 110,000 people trying to purchase it.
Wow! Man,
I'm
jealous. Yeah. I'm jealous because I've heard a lot about Pliny the Younger, especially. I've never had the opportunity to try it. It's very exclusive. But if the Russian River Brewmaster happens to be watching this podcast, leave your contact information in the comments so that Ben and I can get our 12 packs. Like, it's a free plug here. So come on.
Yeah, that's right.
So anyway, it was a fun time, and maybe some not so fun times. I was online with various people trying to get some, and that was a little bit of social fun that we could do together. So
awesome.
And now I get to drink some good beer.
That's great, man. I'm jealous. If you save one for me next time I'm down there, I'll be your best friend forever. But I wouldn't blame you if you drink.
So. Aren't we there already? Chris?
Oh yeah, but just to cement it for all time. Hey, well, that's great, man. It's great to have you guys on here, and super excited to see what you're going to share with us. But Ben, what do you think about our sponsor? You want to run the ad?
Yeah, absolutely. Again, excited to have both Anton and Cam on. We got some really exciting topics to cover with the new HEC-RAS version 6.0. But before we get into that, I just want to take a moment to thank our sponsor for the episode, which is Chris and I's company, Kleinschmidt Associates, who is known throughout the industry as a firm that provides practical solutions to complex problems affecting energy, water, and the environment. You can learn more at kleinschmidtgroup.com. Thank you, Kleinschmidt, for allowing us to host this today. And like I said, we have some really exciting content to share with you guys. But before we get into the new 6.0 release, I did want to kind of provide Cameron with the opportunity to talk about some history. When we had Gary Bruner on a few episodes ago, we really enjoyed discussing, kind of the history of HEC-RAS as a whole, and kind of where that program started and where it's come today and where it's going. So we wanted to give you an opportunity to talk similarly about RASMapper and GIS, and kind of how those things have historically gone together, and maybe how they're separating, and where things are going to maybe end up in the future. So you want to discuss a little bit about that, Cam?
Sure, absolutely. I don't know as though I have the forbearance to know exactly where things are going to go, but I did put together a little geospatial timeline. My lifetime at HEC has been spent on GIS. I was one of the first GIS knowledgeable people at HEC. Most of what I've learned, I learned from one of my mentors and colleagues, Tom Evans, who doesn't work at HEC anymore. He took a sabbatical, went to New Zealand, but he's now back in the States. But I learned a lot of great GIS things from him, and he was really instrumental in getting GIS going at HEC. There was some work done in the 70s, but Tom's arrival at HEC in the 90s was something that really propelled it. I've put together a little HEC-RAS timeline, and as with all timelines related to RAS, it's got to start with Gary. So Gary was born.
We won't say what year that was.
Yeah, we won't say when it was or where it was. But eventually, he found his way out to in Davis, California, at HEC in 1985, and he worked on hydrology and some other things, and eventually he worked on river hydraulics and became the RAS guy. So someday I'm going to get him a license plate, and it's going to say RAS Man. He's going to put it on the back of his car. So the first version of RAS was released in '93, and little did I know that I was one of the first beta testers for HEC-RAS. So I was still an undergrad at UC Davis, and Joe DeVries, you guys can look him up, a great hydraulics guy. He was our one of the instructors, professor, and we had to do a hydraulic design problem, and he introduced us to this new thing, this new piece of software that nobody had seen before. And so it was HEC-RAS. So I developed a model of the Yolo Causeway right here by Davis. I have no idea if I did it right. I have no idea if it worked, but I could get it to run and I could see numbers. So I was stoked. So that was, and then shortly after that, that was the spring of '95. We released, HEC released RAS in '95. At which point it took me until the following spring before I started working at HEC. And when I started working at HEC, Tom Evans had just started developing ARC macro language scripts to extract information to write to a text file that we could then bring into RAS. And so from like late '96 to '98, Gary and Tom and a little bit of me, we worked together to develop geospatial data standard for RAS for bringing in data and then exporting data so that we could view it in ArcInfo. Well, ArcInfo, for those of you who are not familiar, was all command line. There was no interface. It was not an easy tool to use or learn for hydraulic engineers. So as my first major project, I took on developing HEC-RAS interface to go along with some macros for extracting information, develop your RAS model, then exporting your RAS model and doing mapping. So that was really my foothold into HEC and my master's program. And that's how I got started. So since then, I've been involved with HEC-RAS and RASMapper ever since. And so if, a little bit of a timeline from there, shortly after we released the first version of GeoRAS, ESRI released their first version of a GIS that we can use today. You guys have probably all heard of ArcView. And that was released in the, if you look online, it says it was released in like '91, but they didn't have any processing capabilities and really robust functionality until late '90s. And so once that came out, we were like, hey, we got to do this. So worked with Dan Jokic down in ESRI, and we developed the first version of ArcView for GeoRAS and released that in 2002. And so that's when terrain data really started to become available, and you can use it on a regular basis. Not necessarily good terrain data, but data. We had a few more versions of RAS, and then we started to see that ESRI was going to change their software faster than we could keep up. So in 2005, we released the next version of GeoRAS for ArcMap, and I went and talked to Gary, and I remember this so vividly. Like, Gary, we need to do this on our own. We need to have something like RASMapper. We didn't know what we were going to call it at the time. And he looked at me and said, "There's, we can't do it right now. We have too many things on our plate." And I was like, I really want to work on this. Let's do it. And he, couldn't find the funding. We couldn't find the time. So between 2005 and 2007, there was lots of different versions of 8, and then there was version 9. And every time there was a release of ArcMap, we had to come out with a new release because they would keep changing the underlying code. So all the routines we were calling into got to be a real hassle. And somewhere around 2008, 2009, Gary said, "Hey, Cam," I remember this vividly. We were in the airport at Dallas after just teaching a class. And he turned to me, and I don't even know what it was all about. We were just sitting there eating lunch or something. He turned to me and said, "Why don't we have GIS functionality in RAS?" And I said, "Well, I'll tell you why. There's this guy who I proposed this to, and he said it wasn't really a good idea at the time." So I just thought that was funny. So 2009, we decided in earnest we were going to get going on it. And so in 2010, we had the first version. I remember Mark and I, Mark Jensen, we were finishing up the final touches in a dreary hotel room in Minneapolis, St. Paul, raining outside. We were, one laptop between us just trying to get it, finalized. So we got that done. And the first thing we accomplished with RASMapper was to have dynamic maps and stored maps and see the beauty and importance of being able to zoom in, pan around, and not have to generate those static maps that take a long time to generate, because at the time they took a while. And use it as an engineering tool, not a byproduct that we sent off for the GIS people to use in mapping. So I think that was the really great thing about the first version of RASMapper.
Cam, before you go any further, I want to ask you a few questions. So one, who came up with the name RASMapper, and was that contentious, or did everybody kind of agree with the name?
No, it's not ever easy naming anything. I remember, RASMapper, I think we fell onto it because the only thing we could do was map inundation results. So I think it was actually easy. The harder one, a short side story, the name HEC-RAS. So I did that for my master's project, and I was a know-nothing at HEC, still am by most standards. And I proposed that name, and it kind of went up the leadership tree. And I'm not going to say who, but there was someone in the leadership tree, and it came back, and they said, "No, I don't like that name." So I threw out 100 more, maybe it was 3, but when we sat on it for a while. And then about 3 months later, I got a memo come down the tree, down to me, and said, "I really like this name. How about HEC-RAS?" And so HEC-RAS was named, disregarded, and then it came back. So I do remember that one being a tough name. But RASMapper, I think it just kind of fell into our laps. I think it just fit.
Okay. And then before RASMapper was released, did you have the ability to turn on aerial imagery and whatnot in the geometric data editor, or did those two releases kind of go hand in hand?
So before, Mark Jensen had the ability, Mr. Sid. Do you guys remember Mr. Sid raster files?
Yeah.
Those were the thing before we had web services that could service up imagery. And so we were using an ESRI add-in actually to display that data. So static images. We didn't have web services available. There was none of that. It was a static image that somebody had painstakingly georeferenced by hand. But no, with RASMapper, gave the ability to not only create inundation maps, but see them on the fly against background data.
Cool. Okay.
So that gets us to the introduction to RASMapper. And since then, to be honest, it's all blur. It's all been fun, but it's all been a blur. And at that point, we decided, here comes ESRI with another version, and that's where we decided that version 10 was going to be the last thing we supported, because as we went, as soon as I was proficient, there's Arc macro language, and then there's Avenue for ArcView. And then there was Visual Basic for ArcMap, and then they started changing all the routines. So by the time I would get really proficient in it and adding functionality, they would change to another platform. So in 2011, we kind of decided we're going to do our own thing, and it's going to be just in RAS. And so then in 2016, with version 5, was the first time we released the capability to do editing tools. And you could do basic geometry editing. So for rivers, or for 1D models, you could do rivers and cross sections. And I don't remember what else was in there. It's been so long, even though it's only been like 5 years. But and then 2D meshes. It was imperative because RAS 5.0 with the ability to do 2D modeling, it was imperative to do a good mesh. You had to be able to align break lines. And we since added somewhere in there, we added refinement regions, but the idea of adding break lines to the mesh to control faces was paramount to developing a good product.
Sure.
So we did that. And then obviously the ability to extract elevations from elevation data. And then that kind of brings us to the present, what we're going to talk about today and what we're going to be using for the next couple of years. Version 6, where we've really improved the editing capabilities. Alex Kennedy has spent a lot of time trying to really improve the mesh development, the speed, the stability, the ability to fix errors on the fly. So that has come a long way. We've improved the results visualization. We'll see a little bit of that today. And then another really cool thing that we kind of got Alex to do, he spearheaded, was the ability to apply vector overrides to raster data. So that has just been a really momentous thing that he has done, and that we have now the capability to do with our terrain modification tools.
Yeah,
Awesome.
and that stuff is really cool. I've been playing around with it, and it's so convenient and just a great way to make some really quick changes to your terrain. So I imagine you'll be talking about that in a second, right, Cam?
Yes, I will.
All right, cool.
Right.
Cool.
So that gets us up to today, right? So I've heard some rumors and some discussion talking with Gary about the future of RAS, and it sounds like RASMapper, the geometry window, and the main RAS window will kind of all combine into one. Is that correct? Is that what it's going to look like?
Yeah, we've had a vision for a really long time. It's one of those things you know it's coming and you got to do it. But we've invested a lot of time trying to develop RASMapper to be something that is very comfortable for a hydraulic engineer. Like the point of all this is not having a hydraulic engineer have to learn how to use a GIS. We're never going to get away from a GIS, the power of the processing and the data handling. But you don't want to take somebody who's an expert in hydraulics and be like, okay, we're going to slow you way down because you have to go learn this whole another tool. Yeah. So the whole idea of having a map window that we can work in geospatially, we need to integrate that with the capability of doing editing in the standard type of editors that people are used to and that are convenient. And so version 7, the target goal is that we'll have the geospatial interface be the main software program, and then the editors will all be hung off of that, so to speak. So,
nice. Yeah. Looking forward to when that comes out next year.
It's going to take a lot of planning the younger. It's going to take a lot of planning the younger for that to happen.
All right. We get a shit down to you. Yeah. Yeah. Cool.
Yeah.
Well, that's great. Thanks for sharing that timeline with us, Cam. I think that kind of is just really cool for HEC-RAS users that are familiar with where HEC-RAS is today, but maybe have a little bit more appreciation now for where it's come from. So now I guess it's time to get into some cool technical topics for today, specifically, again, talking about some of the new HEC-RAS 6.0 features. And I just want to reiterate for everybody, there is a lot with this new release and a lot that we could spend talking about today, but we'd probably be here for 5 or 6 hours. And I know Cam and Anton both probably have better things to do with their time. Maybe not Chris or I, but so we're just going to touch on a few of the really cool things that have come out. and we're going to touch on them kind of briefly and just have a light discussion on it. But I did want to give Cam a chance to highlight a location where folks can find additional reference material where they can maybe go in depth more on some of these topics and even read about some of the new topics. So Cam, do you want to share your screen and kind of show folks where those particular websites are at, or those references are at?
Yeah, absolutely. So we'll get started by just looking here. If you're looking for the latest in RAS help and documentation, we've shipped PDFs of most everything that we have available with your installation package. So help is available on your computer when you install it. However, we are updating things frequently as we add new features. We're trying to make the feature release more quick, get it out to users more quickly. But we still find, oh, we made a release, we forgot to document a feature very well, or hey, that documentation could be improved. So if you're looking for help, standard HEC website, hec.usace.army.mil/confluence/rasdocs, and it will put you into this page that we're looking at right now, where you can see where you're going to have online documentation for the RAS manual, the 2D RAS manual, what we're going to talk about today, the HEC-RAS Mapper User's Manual. But I won't leave out sediment. Dr. Gibson would just, he likes his water muddy. I like mine clear blue, but we have all the sediment documentation here. And then the two new things we've got up there, we've got a known issues page. So if you run into a bug and you're like, hey, does the RAS team know about this? Go take a look at the known issues page, and it's going to show you for the current release we have out, when it was released, and it will tell you what we know about, what we've fixed, and what we're still trying to get fixed. So you'll be able to get there through the known issues page. So take a look there. If you don't find your issue, then email us. Address is right there. We're going to be excited to see that somebody else has found a bug. I'm sure we will find some today as we're doing the demos. And then we'll have release notes. If you want to know what's in the new RAS 6, we've got release notes here. Gary has a very detailed set of release notes. So some things to think about, and then new things. These are actually the fixes for RAS 6, and then we've got a new features list. So quite extensive set of new features. So this will give you kind of an overview of what to expect.
So it sounds like there's two things that every hydraulic engineer needs to bookmark on their internet browser. One would be the RAS solution blog that Chris runs, and two would be this documents page to have the latest and greatest reference material for HEC-RAS.
Yeah, what's great about this is you know that you're always going to have the most up-to-date manuals. So right. And especially with those known issues. But also I want to mention too, if people forget that web page, you can also get there just from the HEC-RAS version 6 help menu item, I believe, right, Cam?
That's right. Yeah, that's right. We added a help menu item. Actually, I've got RAS up, so I can take a look and see if I can find it. So right off the help manual, we've got all the different manuals that ship, and then we've got the online documentation. So it looks like we have the main page, and then we've got the known issues page.
Awesome.
That's great. Yeah.
Cool. Thanks for showing us that, Cam. So yeah, the things, the different topics that I'm going to turn it over to Cam here to talk about quickly. Again, there's a lot here to cover, but we're going to do our best to get through it. So the four things that we're going to kind of touch on today are the editing tools and end values in RASMapper, the watch list, which is a really cool feature I don't know if a lot of people know about, the terrain modifications, and then the RASter Calculator. So with that, Cam, I'm just going to turn it over to you and let you run with it.
All right. Well, I will again share my screen. Hopefully everybody will take a screenshot of you guys' pretty face so they'll be able to look at it during this instead of the RAS program. Okay, so the first thing that we're going to get started with is we're just going to look at some of the new features in RASMapper. So if you're unfamiliar with RASMapper, in order to access it, we have a quick link button here on the RAS interface. Here I've got a terrain data set already loaded, and that's great. And so a lot of the times, the first few things that let me turn, I'm spoiling the good stuff now. Gotta save it for later. One of the things that I know has been an issue, and that I'm trying to improve, trying to figure it out, is the way RAS works is whatever layer is highlighted in the tree, that's what you're working on. And so there's plenty of times when I'll go in and I'll say, okay, I want to mess with my data set, and I go in and say, okay, I've got my data set, I'm in edit mode, and I want to work on cross sections, and I'm playing with it, and then I need to go make an adjustment with my river, and I go to lay out another cross section, and bam, I start to lay out my cross section, and the river thing comes up. I don't know how many times it's happened to you guys. It happens to me all the time.
Yeah.
And I supposedly should know better.
I don't feel so bad now that I know it happens to you, Cam.
I do it all the time. So what we tried to do is we played with a lot of different ways to try and inform the user what they're clicking on, right? It says it up here at the top, it says it over here at the top left. So now we decided to make a big pink bar, and hopefully that'll
that's great. Yeah.
I don't know, that's one of the niceties we've added with the editing tools.
Nice.
And at any time, Anton, if you think there's something that I am missing, or Chris or Ben, just let me know, because I don't know what's there. We've added a lot of things, just like the tree structure. So right now I'm looking at this tree structure. If somebody just sent you a RAS model, I right away will know what type of model this is. I can see it's a combined 1D, 2D model. I can see they don't have any bridges. They don't have any inline structures. What we tried to do is we're graying out things that are not in use until you've added a feature. So
I see that
really
you have
cool.
some errors there already, Cam. That's not a good sign.
That's like highly likely. Yes, I do have errors already. That's awesome.
That comes as a default, Chris, with every model.
Okay.
Yeah. Everybody has made it. If your model has no errors, then you've done something wrong.
Right.
So for all you new, everybody who's new and old to RASMapper, open up RASMapper and just start editing. Start clicking on there. Right click. Start to see what's new. We've added capability to create bank lines from bank stations, to pull the bank lines to your bank stations if there's a mismatch. Go through and right click on all the layers and figure out what's available to you. Got a river stations table that might be new to you, where you can reassign river stations. So we've tried to bring some of the great functionality that's over in the geometric schematic over to RASMapper, so that you can live more in this area.
You know, one of the best ways I've found to learn new things in RAS is just right click on things and see what comes up. Look at the features in there, try them out, and you'd be surprised at how just naturally intuitive a lot of these features are. I remember from my days there, and I know you guys continue this tradition of trying to really make things user-friendly and intuitive for your typical Windows user. So things kind of make sense. And so it's a great way to learn. Just start right-clicking on things and trying them out.
Yeah, especially.
Don't be afraid to right-click, because you always have the ability to undo. And if you can't undo, RAS should tell you, like, hey, this cannot be undone. Are you sure you want to do this?
Are you sure?
Right.
So not only on that same with that same notion, not only working in the tree, but also geospatially. So notice I went over here to click on the bank line with my mouse, not available because I didn't click on banks first. So right click on the bank and then figure out what's available. So that's there's most everything that's available through the tree is available over in the interface and the map itself as well. So that's a great strategy. Speaking of which, so for those of you who mess up like I do all the time, if you're trying to get to a layer and you want to switch between add new and edit. So let's say you were in add new feed on accident, you didn't want to. If you hit the space bar the shift key. If you hit the shift key,
cool.
it switches you over to the other mode, so you don't have to come up to the bar to get access.
Yeah,
that's really nice.
Actually, I think it's a tab key. Sorry, it's tab. It's not shift. It's tab. The tab will take you back and forth. As you can tell, I don't use it all the time, but when I'm in edit mode, it's super handy. I don't know, guys. Any other editing tools that you guys are super stoked about?
well, there's been a lot of discussion about extracting n values onto cross sections in this new version, because you couldn't do that in version 5, but as I've been told, you can do that in version 6 now.
Okay,
yeah,
so
that was really is when folks ask me, you know, do I need to use HEC-RAS anymore? Can I do everything in RASMapper? My answer would always be, you can do literally every single thing in RASMapper except for extract Manning values to 1D cross sections, but that's no longer the case.
That is no longer the case. That's a good segue, but it reminded me of the one thing I wanted to show before we got there. But let's take a look at that. So right-click on cross sections, you right-click to update. You'll see all the things that we've got added now, and Manning's n values are one of them. Yeah, so that's where you get to that. Obviously, if you choose all cross-section attributes, it will only do the attributes of the cross-section, not any of the elevation information. But we do now have the capability where you can update elevation data for the entire cross-section, for the overbanks only, just the channel. Or we've got a new tool, which we probably won't have time to look at today. It's called the elevation update tool in HEC-RAS. But if you've got that bathymetric data from the drunken boat driver across the river, you can lay out your cross sections and extract elevations.
We've all had cross sections like that.
Yeah. So that's a great way to extract elevations. It's a great way to include bathymetric data into your terrain model. Okay, so let me hit on one last thing for editing before we move on. And that's the idea that when you come into an existing geometry, we're trying to protect the user from accidentally mismanaging their data. And so if you come in here and you're reviewing somebody's model, and let's say we just wanted, in the past, oftentimes you just needed to extend a cross section to improve your mapping, or you needed to change its orientation, but it wasn't really going to affect the river hydraulics. You just needed to change it for how the map would come out. So typically a user would come in here, let's say we wanted to modify this cross section. They double click it and they just drag it out. Well, right now we didn't want that to automatically penalize the user. So what we've done for all geometries, if you right click on a geometry and go to RAS geometry properties, you'll be able to see how many features or attributes can automatically be updated. So right now, because it's an existing model, nothing is going to be updated. All right. So if we take a look at the cross section, we're going to plot it real quick. Let's choose this one. So you can see that my terrain does not perfectly match up with the cross section. So my cross section is shown in green, and it doesn't perfectly match up with the terrain, maybe because I've monkeyed with it, maybe because I've manually gone in HEC-RAS and I've moved this channel over because I know a little bit more. So I've spent some time modifying this channel. Well, if I want to extend this out into the floodplain just for mapping, which I obviously don't need to for this cross section, but if I did, I don't want to necessarily recut the terrain. So if I come in here and I just widen my cross section and end it, I was thinking that was going to auto update. It did not. Now you can see that the cross section is in green and it ends prematurely, right?
Yep.
So that cross section has not been updated to the current data. It's showing you what it will be if you extract that elevation information. So it's not going to affect any of your hydraulic computations that you were previously doing. It's just going to allow you to map the water surface out a little wider.
Hey,
So,
Cam,
yeah.
I think to for the plot to auto update, you want to press the button on the toolbar.
Okay.
Yeah.
Yeah, you're right. Thanks, Anton.
Uh-huh.
So this is
so as long as
yeah.
you don't pre-process this and run it again, it's not going to affect the results, but it will show better on the mapping.
Correct.
So for example, if your water surface was limited because it got to the end of the cross section and you want to see what's going to be the full extent of mapping or inundation here, you can just manually move that over just for mapping purposes.
Right. And I'm not encouraging people to do that, because I want your hydraulic model to be sound. But what I want you to know is that you aren't going to be updating the data accidentally.
Yeah.
So if I did want to update this, so let's come back here. I'm going to undo with a Control Z. I'm going to now go to that geometry, and I'm going to say I want to update specific set of properties. Maybe I want to always update my bank stations, and I always want to update my overbank elevations. So that's now active. So now when I make a change to cross sections, I can come in here. This will be the same guy. Double click on there. And when well, here we'll take Anton's word for it. As I move it out, notice that the cross section got wider.
Mm-hmm.
And it automatically updated. So if we want to see that again in the other, if we want to see that in the other way that we're doing, we can see, plot the cross section. So here you can see the green and the brown, they're right on top of each other. If and this won't auto update, but it'll show you that when I take it out, and then if I plot it again, now green and brown match again. And it didn't change the channel data. Well, who knows if it would anyway. But. So anyway, that's that whole idea of auto update. I want users to be aware of it. You can always go into a cross section. Let's say you've turned off auto update. So right now it says auto update 2 of 10 properties. We're going to turn those off. The other way to do it, which would be more systematic, if you're uncomfortable, is go ahead and move your cross section out, and then you can either right click on the cross section and update the cross section with whatever properties you're interested in, one at a time. You can do it in mass, or you can ask to do the cross sections in the tree to do them all. So just depends on the workflow that you're comfortable with.
So with that auto update turned on, Cam, you could make that change, extend your cross section out, and then simply just go File, Save, close out a RASMapper, and recompute.
That's exactly right.
And it's going to have all those changes automatically enforced. That's
exactly right. So
that's cool.
If it's not an existing data set, so if it's a brand new data set, so let's undo this. So if it's a brand new data set, so this if it's a brand new feature, so this is a new cross section I'm going to add. Maybe I need another cross section in here, and I've added it. So that's what my cross section looks like. Now, auto update should, barring any problems, auto update should be working, and it's just going to keep automatically updating everything as I move. And that's the default behavior of RAS. It's going to automatically grab your river stations, your bank stations, your flow paths. It's going to auto update the elevations in your cross section every time when you're laying a new cross section. Because if you're laying out a new cross section, you want that information. It is not considered old until you have stopped editing. So once we've come over here and said stop editing, once we have stopped editing and saved our edits, it's then from that point forward considered an existing model. And so that's when you'll have to be more cognizant of updating the data.
Very cool.
Yeah, that's awesome.
Okay.
Well, great. And that's a really cool, very quick but informative update on what's new in editing tools. What about land cover, end values, and how we get those on the cross sections or 2D areas for that matter now?
Yeah, so that was one thing that I was never really excited about how RASMapper worked, was with end values, and the fact that we didn't have that capability for a really long time. So with version 6, we've taken a new approach. Version 6 supports precipitation, infiltration, soils data. So we now have the need for multiple GIS spatial data sets that can be in a raster format. So we've approached this with the idea of we're going to be having a raster data set that we want to work with and modify. And the way we're going to modify that is with vector data. So if we take a look here in the tree, well, let's go through the process of just importing one. I've already done it once, but let's do it again. So to create a new land cover data set, we'll go to map layers. We'll say we want to create a new RAS layer. That's going to be our land cover layer. We're going to go and browse out to in this case, my land use land cover data set. And I've got a link here I'm going to grab. So here I've got downloaded the national land use land cover data in the Imagine file format for the entire country. So anytime I do a project, I can just browse on over here and grab it. And so this importer is just like current RAS users should be familiar with. We still have the capability to specify that it's NLCD data so that the IDs will be the same, and then specify a file to import. But what you'll see here is we are on purpose not encouraging you to import and not type in the end values. We don't want you to do it here. We want you to do it later. We want the importer to be generic. And then how you parameterize that data, you think about that later on, because we might use this data for our percent impervious or having to do with something to do with infiltration, right? Might be. So we're trying to genericize, I don't know if that's a word, but make this a more generic later. So you can give your file name, say create, it'll import the data. And then when it comes in, you've got your data, which if I click on this data set, you can get an idea for what the end values are. Here you can see that it's mostly urbanized. So when the data set first comes in, you'll want to come in here, and Anton has spent a tremendous amount of effort trying to make our plotting and symbology just work really nicely. So when it comes in, it's going to come in using the ID. So these are the NLCD integer codes for various things. I don't know what they are off the top of my head. I know the 20s means urbanization. I think open water is 11, etc. So the first thing I'm going to do, I'm going to make it more meaningful to me. I'm going to go, well, that might not be the first thing I do, but we'll do that in a minute. I might make the opacity a little bit lower so that I can see through it, so that I can turn on my satellite imagery and get an idea for, hey, how does this data look compared to my modeling domain? And then I've already cheated and I've already created a channel for you. So what we've done is, well, let's start with the first thing. The first thing you might do is you might come to the land cover data set and you're going to say, okay, I want to edit the land cover. And maybe this is where users like you call in, let us know. Should it say edit land cover data? Should it say edit Manning's end value table? Should it say edit land cover data table? Let us know. Stuff like that. I am always open to hearing from the users. So here we've got, when the data comes in, this Manning's end value column is going to be blank. So at this point, this is all sortable. So I always sort it by ID, and then I have some default numbers I can copy and paste from my Excel spreadsheet from the last time I worked on this study in this particular area. Right now, we allow you to put in a value for no data. I think this only works for the 1D model. For the 2D model, the default end value on the 2D flow area will take precedence. Anyway, provide base end values for your data set.
You type those right here in this table.
Yeah, you type them right there in the table. Okay. And you can copy and paste from Excel. Yep. So It's not too tedious. Now, the great thing that we've added is we've made this so that there's a vector override or vector addition capability. We're calling these classification polygons. So the land cover layer is a type of layer we call a classification layer, where we can now digitize. So here I've digitized a channel. And when I do that, a little dialog will come up. So let's do something different. So in this case, let's pretend, since I am a huge basketball fan, you want to, this building is the gym, basketball gym. It's been weatherproof, stormproof, so no, you're not going to have any flow through here. So as we know, there's two different ways we can model areas where we expect to see high end values, like buildings. So if typically we would recommend that modeling a building, we'd want to use a high end value. And that's a whole nother great beer discussion that Gary and I like to have. Gary likes an N value of like 100. I prefer an N value of 99 because then I know the user did that on purpose. To me,
good point. Oh.
You type in 100, somebody might have meant to put in 0.1 and they missed something. So I like 99, but that's a good beer topic. So
I like that. I'm going to do that.
So if this was weatherproofed and you didn't want to, and normally we use N values because we like to show that there's volume that can be absorbed by that structure, and it's going to pass through the structure. It just might do it really slowly. So we're trying to lower the conveyance. So here we've got highly developed with an N value of 0.1, but I'm going to say this is weatherproofed. Nothing can get in here. So I'm going to go to my classification polygon. I'm going to start editing. I'm going to add a new thing. So in this case, it's going to be a square block. I'm going to add that in there. I'm going to call it, I don't know. We're going to say building, but we're going to say building no flow. I don't know. So we're going to add that characterization. We can put in our N value. I'm going to use 99. Say OK. So I now have this building with that is now overriding my land cover data set. So let's, just so you can see kind of how it works, let's say this building was also weatherproofed. So I'm going to add this building in. Notice it's going to come up with the same name of whatever you did last, and it's going to come up with the same N value. So you are characterizing or classifying the data, and so you can do it in a hurry. When you're done, you stop editing. It's going to ask you, do you want to save edits? Always ask you if you want to save. And then that data will be overridden with the new data. So in that case, maybe I go in and we'll hope this works. We'll reclassify building no flow. We want that to be straight black. Say OK. And to make sure it takes shape. And here we've got building no flow, N equals 99. So that then is the way we're going to define our N values. And then obviously we need to associate those with our geometry. So we're going to right click on our geometry. We can go through it through the geometry properties. We can manage our associations and then associate our land cover with that geometry. So that's the new way that we're handling N values. I think it's going to be more straightforward for users, and it's going to be really convenient.
So let me ask you, Cam, you started out with the NLCD data set, and
Correct.
you brought that into your land cover creator editor. And so that's how you established your new land cover file, which has a land classification sublayer inside of it, right?
Correct.
What if, because there's some people in some countries don't have a national land cover database to work off of, or maybe they just don't want to use it because it's kind of, I don't know, a little clunky, cumbersome, and not always that great in resolution. What if they just wanted to start with their own land classification or classification layer? So with a kind of a blank slate.
Yeah, that's a great question. We're trying to provide tools to the user so that they don't have to use a GIS, it's drawing a few polygons. So in that case, you can go in and you can say, I want to create an empty RAS layer. So whenever you see the word new in RAS, that really means I want to import something. And when he says empty, it means go ahead and create an empty construct or template and then start populating it. So I could come in here, create an empty RAS layer. It's my land cover layer. So we'll call this the VOD LC. Turn off this guy. We'll promote this, move it up one. That way I can still see Google Earth behind. I can then, notice we'll have another classification polygon under here, but I'll be able to, from there, it created an empty construct. I'm going to be able to edit. We'll do the big area first, which is typically what I would have done. There's a way to change priority of the various features, but we're not going to cover that right now. So this is open space. This is my 04. And we're going to draw our building on top. So building 99. So now I can right click that feature. The last created feature is always the feature that is on top. At this point now, we're going to be able to do a geospatial operation, and we're going to clip preserve. So now if we stop editing, so now I have a end value data set goes from 04 to 99. So we have the basic editing tools that you're going to need to create any data set you need for a land cover data set, and that would be how you would do it.
Yeah, and I like the clip feature that you have in there. What I've been doing is, like, if I wanted to now define that area to the right, which is maybe sort of medium density urban, I would just draw and I would overlap it with the existing open space just a little bit, and then just do a clip discard on that. Yeah, so something like that. Yeah.
So we call this Mead development. Maybe that's our 08. Okay, then we're going to do our clip discard.
Yeah.
So it automatically snaps the boundary.
Yeah. So from there you can build your whole end value layer right here in RASMapper. You don't need GIS anymore to do that.
Correct.
Cool.
Very, very slick.
All right.
Cool. So thanks for showing that. That's really awesome, Cam. What about the watch list tool? I know that's something that maybe folks aren't as familiar with, but it's pretty powerful. You want to touch on that?
Yeah. So this is something that actually Anton developed for us. He did a really great job. So the idea is, here I've got 3 different runs. I've got, and I'm going to turn off the maps just so we go a little bit faster. I've got 3 different grid cell sizes, and I want to know what happened to my simulation results. Well, in the past, what do? You come in here. Sorry, we don't want to look at geometry. My mistake. We want to look at results. So in the past, we would come in and we'd want to query depth. So we'd highlight the depth and we go along and be like, okay, it's 13.3 right there. Okay, and you guys stare at that, and then you go, okay, I'll come over here and I'll turn on the depth for the other guy, and then I'll scroll over here and I'm like, well, is that exactly the same spot? Or what you could do in the past is you could right click and then you could plot your time series of depths. So you could always do that and get an idea for how things would vary. But that wasn't the coolest way we could have done it, right? There's always a better way. So Anton added this capability where we can go through and we can add things to what we call as the watch list. So whatever we've got highlighted up in the tree, you can either right click on it and say add to the watch, add a watch to the layer values, or you can just click the plus button down here and it will add it to the list. And then you can say, okay, well, I've got a whole bunch of things down here, and we'll get rid of the velocity there, but maybe I want my terrain. I always want to know what's going on with the terrain. So we'll put that at the bottom. And so when it adds it, for want of a better idea, we always add it with the first letter of the data set. And then we allow you, the user, to come in here and modify it. So I've already modified these to be D50, D200, and D400. So the depth for the 50-foot grid cell, depth for the 200-foot, and so on. So now I can turn whatever layer I want on. So let's leave one layer off. And then as I come over here, I now have a tooltip that's allowing me to compare specific values or give me information at that specific location. So I've found that to be extremely helpful when you're trying to look at compare your results. I mean, we are hydraulic engineers, and our job is to perform analysis. And that doesn't mean laying out cross sections. That's just part of it. The other part is, do my answers make sense?
Mm-hmm.
How am I going to improve my geometry to get better results?
Right. Yeah. Now you still have to have those layers checked on the side, right, for them to show up here, or no?
I think
no, you don't.
Yeah, you don't have to. I think Anton made it so that you don't have to do that.
No, you don't have to.
But
so they don't have
now,
to.
If you wanted, I think what I saw a while back, Gary was showing me some stuff, and you can, with this watch list, you can actually animate 2 layers at the same time by, I think you have to highlight the results group.
Yeah, so when you animate things in RAS, you always, depending on how many layers you want to animate, so let's turn on the depths just for fun. You always have to go to the parent. So if you want everything in the results tree to animate together, you got to go to the results group. If you're in a certain plan, it's only going to animate those layers within the plan, and then it only works on the ones you have turned on. So
that only controls the values that are being displayed. Does it actually, can you actually control the display from that window, or is the display still controlled from the results section?
I don't think I quite understand, Ben, but you control everything from over here.
So I guess what I meant is, so the new watch list that you created, can you actually change the visual display of depth? Or I should say toggle on and off the visual display of depth for those different plans from that, or do you still have to do that from the results section?
Oh no, you can do it. You can do it down here. Yeah. So this guy is its own. It's essentially its own separate window. So I just popped it out. It's its own separate window. It controls itself. So you can add the things that are very important to you and then turn them off and only look at the one that you want to look at. Regardless of
that's just turning off the actual numbers that you see, but the inundation is still shown because it's checked over there under results.
Correct.
This is a great tool to, if you want to compare inundation extents between 2 different plans, you could turn on your water surface elevation for both and animate them, and they'll animate together by doing this watch list.
Correct.
That's awesome.
So I think that'll be really handy. I think this has just been from an engineering standpoint, super helpful when you're doing that levee design and you want to know, how high is my water surface compared to my levee for my 3 different plans. You can turn them on. You can have that terrain with the levee layer turned on and just compare the different ones. So super helpful, I think.
Yeah, definitely. What about some of these terrain modification tools that you've added in? Let's see that.
So the terrain modifications, just for a little history, or this is going to be long, but just for a basis, is the idea behind the terrain tools is right now we're limited to raster version of the terrain model, and as we know, that's not the highest fidelity terrain model that we'd like to deal with. And it really became a problem when we had these combined models. So we look at this model here. We've got this combined model where we have a levee system that's running between the 1D model and the 2D model. And you start to realize that no matter how good your terrain model is, you're never going to represent that levee with the coarse resolution of the grid. But the grid's fine for everywhere else, just not for these linear features. So we really needed a vector addition. So we've gone to the idea of the raster data being the underlying body of work, but that we can then modify it, the terrain layer, with vector additions to have more precise data handling. So a few things that we've added. So we'll look at the terrain. the way we can start looking at this is the first thing we want to do is we don't necessarily want a copy of the terrain model. We've built this in a way that it's modular, so we can point to a terrain model and then just use it. You know, think about your studies where you got 15 gigabytes worth of data. You don't want to make a copy of 15 gigabytes of data just to add a levy that's, you know, a few kilobytes worth of data. So the first thing we want to do is clone the data. So we can clone it. In this case, I'm just going to call it clone. It's going to add a suffix to the end. And as I turn this on, you'll see it looks just like the other one. So it's an exact duplicate of this other guy up here called terrain. It's just we created an HDF5 file on disk that points to that terrain model. Now, at this point, we want to perform our modifications. So we'll right click on it and we'll say that we want to add a new modification. And we have 3 different ways to do this. We can do this through a simple shape, which we're calling like circles, which we would do for simple things like piers, a rectangle, a simple rectangular pier, or a triangle. Maybe whatever ways you can think of doing that. We also have this thing called an elongated pier. We'll take a look at that in a minute. We have the ability to do lines. So we have a high ground line or a levee line. We have a low ground line, which is just flip the script and let's look at it upside down and make a channel out of it. And then we have the ability to do polygons. So we'll do a quick example of each just to get an idea for how it works. So the first thing we might want to do in this model is we might want to add a channel. So let's go and we'll add a channel. We're going to name this group channels because you can have multiple features then in this channel data set. So I'm going to zoom in here where we clearly need to have a channel. And we're going to start. Oh, it's already in edit mode because we added it.
That's where the bridge was picked up by LiDAR, right?
That's where the bridge was picked up by LiDAR, exactly.
Yeah.
So we've got the bridge, and it no big deal for a 1D model, but for a 2D model, it's death. So, and the one thing, let's another little trick we can point out to the users. So here I started editing, and I didn't see the editing tools. The editing tools are only active when you have the selection tool available in the window. So that's a good little trick. Every once in a while, this toolbar will be grayed out. My heart will skip a beat, and I'll wonder what the heck we did. And it's always user error. So we're going to add channel here. So I'm going to start my channel up here, and I'm going to run it down through here. Okay. So what it's going to give me is the ability to make a template of what the channel looks like, and it's going to allow me to put it on slope. So by default, it took the elevations from the terrain model, which is actually pretty good. Let's pretend we want to use those. It's going to allow me to specify a bottom width. Hopefully, I would have had my act together before I did this and known exactly what I wanted to do. But you can see 20 is not quite wide enough. See, our bottom goes there and it goes up to the side slope. So the terrain is already being modified as we're working. So let's try 40.
That's cool. It's like on the fly.
It's cutting it a little bit wider. Maybe we'll go crazy. We'll go 100. We'll see what happens. All right, we'll call that good. It's going to allow you to do your side slopes, horizontal, vertical. Not going to worry about that right now. But so we'll call that good for our channel. Say, okay, the channel data has now been applied.
Wow, that's so quick.
So it's pretty slick. Now we've added our channel. Now what's the other thing we need to do? Well, and actually let me modify this. This is great to show you guys. So I don't like exactly what happened, so I'm going to edit it, and I'm going to make this 200. I want to really blow that channel open, because the next thing I want to do is I want to add in some piers. So I'm going to go to modifications. I'm going to add a modification, and this time I'm going to do a simple shape. I'll just do a circle. And I can call those piers or whatever I want to call it. Now, we have a default size. So I've got default sizes that are going to be what I think are visually appealing and realistic. So the default I think here is 10 foot. If you want it to be bigger or smaller, maybe let's pretend you're placing it where a bridge got blown out, but the piers are still there, and there's an aerial photo, so you can see exactly how big it is. You can hold down the control key, and you can scroll the wheel, and it's going to make it bigger or smaller for you.
Cool.
All right.
Very
so
cool.
maybe that's 20. Okay. So we'll put in 2 piers. They'll be gargantuan. They'll be 20-foot piers. We'll put those in. It's going to automatically add it. You can choose. You can make it elliptical. If you make it elliptical, it'll give you a minor axis as well.
It's actually the radius too, so it's even bigger.
Yeah. Oh yeah, it is the radius. So it's a Mondo one, but everyone can see it on screen, I hope.
Yeah.
And then you put in your elevation. So I think 945 might work. I'm not exactly sure.
And that's the how high you're going to lift that terrain out to 945. Okay.
I mean,
So
couldn't you also add the height?
You could. That's not the way we would do it in this case, but
Oh.
you could, and we'll get there, Anton.
Okay.
So, so here I'm just trying to figure out. I don't remember off the top of my head, like what the top of the roadway was, but it's somewhere around 950. So we'll go 952 and hit OK. Well, actually, we'll hit apply. So that's one mode, is just to replace the terrain. As Anton just brought up, and this is just a fine time to point this out, there are multiple ways, multiple methods for applying this, any of the modifications. I tend to use replace. That seems to me the most straightforward, but there's other ones. So you can choose to take the higher value between the terrain and the elevation you type in. And I typically use that maybe for a line, if I'm just trying to fill in where a roadway would go. You can choose to take the lower. So when we do a channel, we're doing this take lower. When we're doing a levee, we're doing the idea of take higher or replace. Or you can just add a value to the terrain. So if you want to add a picket fence that's 5 feet high, you can say add whatever value you put in, and then you could add. It'll follow the terrain profile, but add that value to it.
Mm.
So those are the 4 options that are
Nice.
available. So we can add a pier. That way, there's also the capability to add a more fun pier. So circle, rectangle, triangle, those are all the same. But maybe we want to add a fancy one. So that one we reserve the name pier for the fancy one. And so when we lay out that, what you can see, and I'm gonna make this. Oh, we don't allow you to. It doesn't scroll big yet. So what it allows you to do.
Can't scale it yet, unfortunately.
Yeah, we'll scale it soon. So let's say our pier is 200 foot long, and we're going to use rounded edges with a radius of 5 feet. That'll be small. And let's make it 20 feet wide as well, so we can really see it on the screen. And we're going to put it at 950 elevation. Say OK. So here we've got a pier that was created. Now in this case, I'm going to go in, I'm going to select it, I'm going to rotate it so I can align it with flow. And so now I've got a pier that it's elongated, it's got a rectangular shape to it, and the nose, in this case, was rounded. Now we also had the ability, if you noticed, we could do sharp nose. So let's make these a little bit bigger so you can see them just a little bit better. And so you can do a sharp nose on one end and a round nose on the other end. And now you've got a pencil pier. So anyway, I think that's going to be a great option. It's going to, between all the pier tools, all the simple shapes, you're going to be able to handle all the different piers that you need. And again, with a circular one, we didn't need to rotate it. Obviously, with the elongated one, we needed to rotate it. You could type in an angle, but it's always easier just to align it with the bridge.
Very
all right,
cool.
so that's that. Let's zoom out.
Let me make a really quick comment, Cam, because
Yeah,
I'm
absolutely.
thinking some people might have this question right now. But
Okay.
now that 6.0 can do 2D bridges, and we can clearly see it's very easy to put piers in here. But one thing you would want to make sure you don't do is add a pier in the terrain like we've just done here, but then also include a pier in your bridge editor when you put that in, because then you're going to be double counting that loss. So you want to do one or the other. The nice thing about having it here in the terrain is you'll be able to see the water go around the pier, versus if you only add the pier in the bridge editor and not in the terrain, you're not actually going to see water going around the pier.
Right. That's right. So I think using the terrain modifications is going to be more for when you want to do detailed analysis at a bridge.
Yeah.
Whereas the 2D bridge modeling approach is going to be for the more rough analysis, where you're trying to get a good water surface profile and you don't necessarily need the velocities or to see the velocities for pier scour.
Yep.
Yeah. So that's a really great point. Really great point. So the other thing I think people are going to be interested in is our high ground option. So let me zoom out. Again, Anton has worked tirelessly on a lot of these terrain modification tools with me to get them implemented in a, oh geez, do that all the time. Accidentally zoomed in. He's worked tirelessly with me to add capabilities that we really think people are going to use. So one of these is definitely going to be, hey, I got a levee. I got to add a levee. So it's my high ground option. We're going to add the high ground option. Now, obviously, we can create our levee by digitizing. And you guys already saw this with the channel feature. It's exactly the same, only in this case, we're taking the higher of the values rather than taking the lower of the values. Okay, so the two tools are exactly the same. They just are working in different capacity. So here I've got my levee, and it starts by taking the elevation where you first click and where you last click, just to give you a slope on the line. So we're going to make the levee 40 foot wide so we can see it. We're not going to worry about this other stuff, and we're going to add the levee into the terrain. So we'll say okay. And when that line gets unhighlighted, you'll be able to see it in the terrain a little bit better, right? So you can see the levee has been added.
So let's say you've got some LiDAR and it's not the greatest quality LiDAR, so you've got a lot of ups and downs along the levee crest. This would be a great way to kind of lift that up to the actual true levee crest elevation.
Exactly. So we're going to be overriding that data with this better data. So that's the rudimentary way to do this. Now, there's other ways we can do this. Let's add another one. Well, actually, let's continue with this one right now. So we just picked a couple elevations, and if we were to edit this guy, we can type in other numbers. If we want this to vary more frequently, we can type in a number. So let's put something at 5,000. And we'll put it at elevation 945, which might be on the same slope. Notice the table gets resorted, it gets inserted to the right spot, and now we have a different shape to it. And maybe that's too high. Maybe it should have been 940. It's more realistic. Whatever we want to throw at, we can type things into the table. It's going to sort it for us and recompute it. And that's really handy, but that's not necessarily the best way. A lot of times we're going to have survey data. So we can go and we can use this thing called elevation control points. So we can go in and let's say we know the elevation right here starting. Let me zoom in so everybody can see really well. As we get close to the line, you can see the crosshairs snap to it. That means when I click, it's going to get snapped to the center point of the line. So that's great. I'm going to snap it there. It thinks that the elevation should be 946 because that's what the override is telling it should be right now. But I say, you know what? I have real data. I have a benchmark. I want that to be 950. So we type that in. It automatically gets applied. We can then go through all of our data by hand if we need to and enter some data. So I'm going to put two 950s in there. And then we're going to go look at the high ground. So now you can see I've got 2 rows in my table with the elevation 950. You can see that they have been grayed out. That means that they've been entered as an elevation control point. So that's a second way to override the data.
Very cool.
So when you type that 950 right there on the schematic, it lifted up that part of the levee plus some distance upstream and downstream of it, or how does that work exactly?
It applies a point internally, and then we interpolate. So what it did, here's the profile of the line. So yeah, we inserted it, so it's interpolating from 949 to 950 up here at the top.
So okay, so what you just did on the schematic was essentially the same thing you did here in the table. It's just a more graphical way of doing it.
Correct, exactly.
Also, you can import the points.
Right. All right, so that's the second way. And then as Anton was worried I would forget, another way we can do this is we'll add another modification for this one. So we'll add another high ground. We can then import. So we're going to import features from shapefile. So if you have a shapefile that has Z, so this is a really nice importer Anton's made. I'm going to see if I can find a shapefile here. All right, so I had a little section of the levee upstream of where I was just working. It's already got the Z values in there. If there were multiple lines, you could choose which lines you wanted to import. So we're going to select it. We're going to import it. It came in down here. So we'll zoom in and take a look. This is our new line. And then got a little bug right now. It hasn't exactly been applied. So we're going to right click on it to edit. And then you can see it took shape. So we need to refresh the plot right there. So here you can see that the data should have been imported from the shapefile Z. Maybe there was only 2 points in it. This looks mysteriously not right, like there's something wrong with my shapefile. But that's one way you can import. The other way is directly from here, you can import a shapefile. If you import from shapefile from this editor, it destroys all the data. We're going to import the same thing and see if we get the same answer. Doing a little bit of bug testing as we work.
Sure.
Oh yeah, GIS data, levee Z, levees with elevations. Hey, it looks the same. Should replace everything. Now it says the shape you're importing as Z values. Would you like those to replace it? And you say, heck yeah. No pun intended. And so here you can see station elevation data did replace. So that other importer is not working quite right. This importer is working correctly. So now you can see it following the elevations as was expected.
I think it put the XY data in, but not the station elevation data. But
Correct. So we got to work on that. But anyway, if you want to change the XY coordinates, you can copy paste, type those in by hand. That's available to you. I don't really see anybody doing that by hand. I see a lot of import type options. So those are the terrain mod options that are at your fingertips, at your disposal.
And that is going to be so useful, guys. Thanks for adding that in and showing it to us. Yeah, and let's move on to the RASter Calculator. That was something that I know there are a lot of people interested in this. One of the biggest questions I've always gotten is, well, how do you compare output maps one to another to see maybe what the difference is between a couple plans? And we've never been able to do that right in RASMapper, but now you can in 6.0 with this RASter Calculator, right?
Correct. So as I showed you earlier, you could right click and get a hydrograph at a point. Now we've added the layers, the watch list, which obviously is super helpful. But if you want to do this on the big scale, then we've added this tool which allows us to analyze dynamic maps together. So we've added under the tools option. Create calculated layers. And this brings up a RASter calculator. Now, this is not intended to intimidate anybody. It's intended to just, be a breath of fresh air, but I realize it looks a little scary.
Just wait till you put the code in there.
Right, exactly. So you can do it by hand yourself, but what we're going to try and do is we're going to try and get the community to start submitting scripts to us that then we can share with everybody, that can ship with the next version of RAS, or we can put them on our web page for people to go get. Hopefully open up the communication, maybe put them on the RAS solution. By default, I've got 3 here that I know people always are going to want. They're going to want some sort of hazard scripting. They're going to want to compare water surfaces, and then they're going to want to do depth times velocity, but maybe to some power that we don't have, 1.5 or whatever. So we'll go with the simple one right now. But when you bring this in, all the train models you've loaded are automatically here for you to use. And then we're going to compare water surfaces for this example. So here's an example of the script. Yeah, it's a little overwhelming. But when you start looking at it, a little bit of practice, I think it'll be not so bad. So I had terrain with channel turned on. So that's what got added in here. And what the script essentially does, this is telling you what's going to be used. So my variable, water surface 1, water surface elevation 1, is the cell value from my result, which was grid 50 foot, using an elevation. It's going to use the dynamic profile. So that means as I animate, it's going to animate. And then for variable number 2, it's going to use the plan that was the 200 foot grid cell plan with the elevation data set. And so this script goes through and it sets it up so you can be successful creating your own script. It says, if I have data and also I have data, then, if I don't have data, that's what no data means, and I don't have data, then don't do anything, don't do a calculation. Otherwise, if I have some information, then start working with the data. So I'm going to analyze my water surface variable, number 1, with water surface number 2. And if either of these data sets don't have any data, then just default back to the terrain value. So it's a pretty simple script. Allows you to define what you want the name to be that's going to show up in the layer list, and then what you want it to be, where you want that script to be stored on disk. So let's just hit create layer right now, just for fun. That guy should have gotten added in the map layers because it's comparing, in this case, it's comparing multiple layers. If you're only working within one plan, it will go in the results file. So we'll turn that guy on. Let me turn off this terrain. We'll turn that terrain on. Okay, so by default, it's not a very pretty map. So we're going to go in and we're going to come up with some sort of scaling option. So we'll do a max of 2 feet, and then we'll do 1 and -1. How about that? So we'll assume that our differences aren't too different, and we're going to create a color ramp. We're going to go from red to blue. Create the color ramp. Oh shoot, reset my colors. Rookie mistake. All right, say okay. So now I come back to my result, and maybe I want to look at the max. Let's look at the max just for fun. And you can see that that's not showing me a lot of differences, right? So depending my results, comparing my 400-foot grid cell size and my 50-foot grid cell size, or whatever I was comparing, they don't vary by too much. So I would need to, at this point, go in and I would change my scale. So let's go from 1/10 of a foot to -1/10. All right, so that's giving me a little bit better answer. So it's giving me a little bit higher water surface up here where it's blue, and then you can see it transitions into a negative water surface through steeper terrain, and then down here it's, again, not quite as negative, but the answers are pretty much very, very similar.
So purple here means not much difference at all between the two.
Correct.
Red and blue shows where the differences are.
Correct.
Awesome. That's great.
So
hey, can you show that code again really quick?
Yeah.
There you're on top of it. I wanted to point out for those folks out there who aren't familiar with scripting or writing code, here in the Visual Basic code, when you have that apostrophe at the beginning of a line, that's just a comment. That's actually not code that's used. It's just there for a description for you to write. The actual code here starts at the if line, and it's that if, else, and if, and that's the code that's being run. But it looks like you can use a different language up there too if you want.
You can, and I had a knockdown, drag out beer drinking session with my colleague Alex Kennedy. And because he's a super nerd with the programming, he's like, well, everybody should know C#. So C# is in there if ever anybody wants to get excited. And that's the language they're comfortable with.
I'm sure a lot of people are going to be asking, why didn't you put Python in there?
They probably are, but we're using the .NET compiler. So this is actually like all built in, and it gets compiled on the fly. And the .NET compiler is what we're using for RASMapper, so that's why that's there.
Yeah.
So we've got this little code window. We're not going to go into details today. That's not the type situation we should be doing this in. But what I do want to help you with is you can create your own code. You can save. You can load the script. So if I wanted to load a script that was already on disk, you can do that. We're appending RAS script onto any of these guys. They're stored on disk. You can send it to a friend. It's just a text file. And if you want to know if your code's going to work, don't just hit go. We have this little view full code window where I've got a nice little editor that tells you, hey, it's going to compile. This is all this grayed out stuff is all the behind the scenes stuff that we need to do to get the code to compile. And then this is just the meat of your actions is down here. And it continues down to the end here. And then we've got some things down at the bottom, which we store so that we can load and save data.
Nice.
So that's your introduction. Now, I will say the first comment anybody out there is going to give is, what if right now RAS works with dynamic layers that are created within RAS. So the first question anybody's going to ask is, what if I have a stored data set on disk? We will hopefully have a button to allow you to add a stored data set to disk. It might not work with some of the sample code, but we're going to, we've already added it. It's in the debug version right now. So there's a button where you can add a stored data set in there. But we don't have that in this version at this moment.
Okay, so the RASter Calculator only for dynamic maps at
Correct.
this point.
At this point, because then you can go through and you can play them and that sort of thing. Yes, Anton.
Isn't there some pitfall with max data sets using the RASter Calculator?
There is. Those are the inherent problems that folks should be familiar with, like for max velocity and using max velocity at the same time with max water service profile. If you're trying to do that, the maps that you're going to create within RAS will handle that okay, because we brute force and figure out when you had the max depth time, excuse me, max depth times max velocity. We brute force for every time step when that's appropriate. In this case, when we're using the RASter Calculator, we don't have that capability to brute force, and we're just looking at time steps. So max depth times max velocity is not always going to give you the answer that you're hoping for. But that's a little bit more complicated problem than we have time for today.
Great stuff, man. That is super cool. Well, wow, that has been amazing, Cam, and you've covered a lot of ground, and I hope people really find this useful. I know I do, and I'm excited to give some of these things a try. But we've got Anton here, and he's got a really cool thing to share with us called the 3D Viewer and the Google Earth demo. So I'm going to turn it over to Anton and let
Okay.
you go wild with that.
All right, cool. First, I will share my screen. Otherwise, we don't have a podcast. I'm not sharing my screen.
Yeah, the 3D viewer is not something that you can just talk about. You got to see it for yourself.
You got to show it. Yep.
First, I'll show the various ways you can get it going. I believe there's 3 ways you can get it going. The first way is on the main RAS window. This is a button here. You click on it and it will bring the 3D viewer up.
It's that little cube looking button, right?
Yeah, I made that cube.
Yeah, it's a nice looking cube.
And then the other ways are in RASMapper. You can either press the cube button on the top here, or you can right click a map and press the cube button, or right click a result and press the cube button. So wherever there's the cube button is how you get to the 3D viewer. For today, we're going to take a look at a terrain from and a model from Reno, and I picked Reno because it has all the buildings in the terrain, so it's interesting to look at in 3D. And there's verticality too to the water. If we look at the water surface elevation, well, I thought maybe this. I mean, that is a big jump, I guess. I thought this was a little bit different, but we're going to like 4,500 to 4,300. So there's a lot. There's a difference in water surface elevation there, so you can see kind of how in 3D how the water will flow in the Z axis there. So we're gonna take a look at Reno now on the 3D viewer. The first thing that will happen, if you've never run the 3D viewer on a data set before, is it will pre-process the data set. It'll create a file in the same folder as your project. And the reason we pre-process is a lot of the processing done for getting the water in many little RASMapper screens. That's actually what the 3D viewer is made up of. It's like little mini RASMapper screens. So that takes a lot of CPU power. And by pre-processing, we take some load off the CPU and put it on the hard drive. So our CPU can focus on rendering the terrain or grabbing the appropriate time step or water or whatever. It's just, it makes it run better. You can always cancel the pre-processing step. You would have to hit the cancel on the loading bar that we saw earlier. So here we are, same view as RASMapper. One thing I want to point out is on the animation bar, we have a green bar, and the green means ready to go. You can just click and let go, and it will almost load almost instantly. I think it's even faster in RASMapper, and that's all thanks to the pre-processing. So here we are. We can kind of like control the viewer as if we were in RASMapper by middle click and drag, and you can zoom in, and if you're familiar with the RASMapper controls, then this will be like right at home for you. Before we get flying through, I just wanted to take a look at all the options in the 3D viewer in case you want to change some things. And what happened? Oh, there we go. So full resolution water during animation. Right now, when you animate the water, we scale down the water so it animates faster. Maybe because you are animating, I would guess you wouldn't care too much about how accurate it is at that particular time step because you're only seeing it for, a split second. So it's off by default. I can show quickly how it looks like with that. You saw how it was a little blurry, but when I stopped, it got sharp again. If you hit the checkbox and apply, and we rerun the animation, it's a little bit slower to animate. Not much, yeah, it's a little bit, see how it's slower, how much slower it is to animate. So.
But it's a crisper view of your water surface.
Yeah.
Yeah, very cool.
So I leave this off. You can change the scaling of the terrain, the exaggeration here. If you change this, you'll have to restart the viewer. So I'm not going to change it. And then you can change the various symbologies for the map types and your terrain if you're used to a different symbology. These will come over from RASMapper. So if this terrain was already a certain symbology, you don't have to worry about setting it to something else here. And then the graphics, the only real thing you can do here is change the resolution of the window and the level of detail. And since I have a beefy graphics card, I can use high level of detail. But if you're on a laptop with integrated graphics, maybe you'd want to use the low one. Or the medium one. You just have to see if it's smooth enough for your computer. And then we also have a shading mode, and you can really see the difference in shading mode on these buildings. Although I think I have to restart the viewer, but the shadows here would look sharper with the sharp mode on, but at a cost to performance. So less, it won't be as smooth when you're looking around. So it's defaulted at smooth, but if you want sharp, you can do sharp.
Got it.
And then the controls, you can change the mouse sensitivity, and that mouse sensitivity comes in play when you're panning with your mouse, not like this mouse that you see now, but only when you're panning. So if you find that while you're panning, you're moving your mouse over to the center a lot, you might want to increase the sensitivity so that you don't have to do it so often. And then this is analogous for the controller. You can invert the controller looking up and down. Some people are used to the controller being inverted. So if you put the stick down, the view will look up. Some people are just used to that from gaming or from flight sims or anything. And then here you can change the bindings. These are the default bindings. You can have it look at that on your own. Oh, and the controller bindings here. You can't change these yet. They're just here for your convenience to look at, see what they do. And then the particle tracing options are similar to what you see in RASMapper, so there's nothing to cover there. All right, so right now I'm changing my view with my mouse, and I right-click to look around. This changes the rotation, and then as before, you can middle click and drag, and it will, if you're used to clicking and dragging in other applications, they'll translate to this.
Wow.
Does it work the same way that Google Earth works with the mouse clicks? And
no, not quite. They're like swapped. So like middle click is actually right click in Google Earth.
Okay.
The only reason why they're swapped is because people are used to middle clicking to move in RASMapper. So that was, maybe I can put in later on a way to change that around. But for now, there's no way to change that. So you can also move with the keyboard. If you're a PC gamer, the WASD keys should be familiar for moving around. If you want to increase the speed, you can use your left and right arrow keys, and it will increase the speed of the viewer. You can see the current speed on the bottom left. So 48. Top speed is 48. So if you're going too slow or too fast, you can change it there. The last thing for controls is you can press the tab key and my mouse will disappear, and then you no longer have to right click to look around. And this will make this makes it, in my opinion, better if you're showcasing with the mouse and keyboard, because it's really easy to just go forward and look around with the mouse without having the right click.
Yeah.
So Anton, I'm intrigued about all the buildings you have in here. The terrain, I assume, comes from RASMapper. Where do the buildings come from?
Yeah, the buildings are also from the terrain from RASMapper. This data set was built with the buildings in the terrain.
Okay.
In the future, we want to have a separate building layer and be able to maybe perhaps import building data from like OpenStreetMap or another source, and it would show up just for visualization purposes, maybe not for hydraulic purposes.
Okay.
Yeah. If we ever want to go back to the center of the map, like how it would react in RASMapper, you just click this button here. It brings you back to see everything. And then it's if you get lost. Another thing, if you get lost, is you have a little mini map here. You can see where you are in relation to the terrain. So if we're off into space and I'm like, I don't know where I'm at, you know what I mean? You can just tell that you're here. If you want to move without dragging or using the keyboard, you can click the mini map and it will just place your camera there. You can actually hold down the mouse and control the viewer that way.
Great.
And what if you're like, oh, I don't need to see the mini map. I'm really familiar with this terrain. How do I make it go away? There's a minus button. You just click the minus button and it goes away. And same for this legend here. If you don't care about the legend, you can always just make it go away there.
Super cool.
That's that.
That's great.
There.
And again, if you wanted to like show the flooding at some specific location here, you could pause here and you could animate it. And you'd see the water come in and rise and go into the city area and then come back into the channel, right?
Yeah, we'll get to that with flight paths.
Oh, okay.
Yeah, this is just all manual control. If you're confident about controlling, you don't need a flight path, or you're just showing a colleague, or I don't know. It doesn't have to be like a formal kind of presentation. Just to show what kind of maps you can do in the 3D viewer. This map here, it's not in RASMapper. I call it the realistic map or realistic water. And you can see the texture is changing depending on the velocity, direction, and magnitude. And it kind of sparkles because of the sun beaming on it and all that.
Yeah, that's cool.
You can click this button and it will change the map. It'll cycle through the various maps. The next one is the depth map, which everyone's familiar with. And same with RASMapper. If you're curious about a value, just hover your mouse over and it'll tell you the value
Oh, that's sweet.
Yeah. And then the other one is velocity. We all know what a velocity map looks like. And then we have water.
You can't draw profile lines in this, can you?
No, we don't have any kind of thing like that yet. It would definitely be in a future kind of thing.
Sure.
Yeah, I guess water surface elevation is not very meaningful here. So we'll go back to realistic. And then particle tracing, you press the button here or you press P and you get particle tracing in 3D. And this actually updates while you move in space, unlike RASMapper. It's not perfect. The slower you go, the more it can keep up with like loading while you're moving. So if you ever need to, you can always just, if you're making a video or something, you can always just speed up the video, right? So there's that. I don't believe particle tracing works while you're animating, but only while you're flying around. So one last thing, probably what people will use the 3D viewer for is the flight paths option here. And you have to make a flight path in RASMapper first. So we'll go ahead and do that.
Okay.
So we'll come back to RASMapper and we'll go to the features group here. And we're going to add a new layer. And we're going to add a flight path layer. And I'll just call it flight path. And right now, the flight path layer is not too different than the polyline layer. Hopefully in the future, you'd be able to like designate points where you can keyframe like elevations or keyframe a transition. So you can say, oh, I want the time from here to here to be 2 seconds instead of just using the 3D viewer speed as it does now. And you can say, oh, I want the point from here to here. I want the elevation at this point to be this, and the elevation from this point at this point to be that. And it would, it would change elevations along the flight path, but it doesn't do that yet. That would be in the future. So I'm just gonna go down the river here, start delineating roughly. And then we'll come back around.
If you already had a river center line, you could copy and paste that in and be a lot quicker.
Oh, that's cool.
Yeah, you can copy lines from one layer to another layer in RASMapper. It should work. So that's it, stop editing. And then we're gonna go back to the 3D viewer. All right, so we're back in the 3D viewer and we have our flight path. So we're going to look for our layer that we made in. This is our flight path that we made in RASMapper, and it highlights here so you can see where if you have multiple lines, you can pick one. Right now, the only options is a constant elevation, which you can change while you're flying, so you can scroll up and down. You can make it so that the camera will always look forward, kind of like a trolley. If you look around, it will pause the viewer, or you can free look. So if you're more advanced with looking, or you already kind of know what you want to look at, you do a free look. So I'll do free look here. And then you can either start from the beginning or from the end in the polyline. So we're going to go ahead and start.
What's the elevation it's going to use?
It's whatever we're at right now. So I'm probably gonna have to go
zoom
down.
in. Oh, okay.
Yeah. And it's on free looks, so oops. Looks like there we go. So I'm gonna get down closer to the channel. And while we're on this cart here, we can animate.
Oh, at the same time. Oh, that's neat.
I'll advance the time here so it's more interesting.
So you can ride your surfboard down the flood wave as it you time it up just right.
Yeah, as it's happening. So if you want to change the speed, it's the left and right arrow keys. Like right now it's going really slow. And this is fast. If you ever want to turn around, just hit the change directions button, and we're going the other way now.
And for the free look, what do you use to control your free look?
Same as just looking normally. You hold right click down and
Okay.
look around. Or if you hit tab and you make your cursor go away, you just move the mouse.
Okay.
Yep. So like, let's say on our path, we want to look at something. We can always click and drag. Sorry, I guess that doesn't work. You can only move with the keyboard, and it will pause the flight path for you. It'll remember where you were at. Like, let's say we want to look over here or something, or go back to over here, just show the animation here for whatever reason. Let's say I want to go back to playing flight path. I just hit play, and I'm back on track where I was. Yep.
Super cool.
And then can play particles too while we're flying here. So
that's really neat.
We'll have to ask Mark Forrest if he watches this, if he's flooded in any of this. I know he lives down in Reno.
Yeah, he lives up on a hill.
Oh, he's got one of those houses. Okay.
Yeah, it's all right.
Or one of these.
As a good flood modeler should be on the top of a hill, not down in the floodplain.
Oh yeah, one last thing. If you ever need help in the 3D viewer, if you press help button here, it'll tell you how to do everything that's important, like moving, changing your view, changing your elevation, and the mouse unlock, lock. And then if you click here, it'll take you to Confluence, and you can always see the Confluence docs, which are more in depth, and they have cool pictures and all that.
Nice.
And that's it for the 3D viewer.
Man, thanks, Anton. That was a really cool demo, and I'm super excited to give this a try and play around with it and see what we can do for some presentations.
Yeah.
Definitely.
So,
thanks, Anton.
Regarding the future, I already explained a building layer. So maybe these would be in a building layer instead of being part of the terrain. Another thing is the 3D viewer kind of chokes on big terrains, really large terrains. Like we're talking a couple gigabytes. And it takes a while to load. And I'd want to make it so that the terrain can stream in a sense, like, so you don't have to load everything beforehand. It'll stream in. So it would drastically improve the loading time for large data sets. And what else? I think those are the two major things. Is there anything else I'm missing, Cam?
Imagery draping.
Oh yeah, that's right. Yeah, right now you can't drape aerial photography on the 3D viewer. That's probably the next thing we're going to do because that's important. So,
Oh yeah, so you get a realistic like satellite view instead of terrain view.
Yeah.
Yeah.
I mean, it won't be as good as Google Earth, but it's something. So
Nice.
now we're going to take a look at another way to look at your data set in 3D using Google Earth. Get out of the 3D viewer, and we're back in RASMapper Reno. And the first thing you want to do if you want to make a data set work with Google Earth is you want to make a inundation boundary map. And you can do that by right-clicking the result and create new results map layer, and then selecting the inundation boundary type here. And then your profile, most people want to do max. So it's max by default. And this is a stored map. So after you add it, you're going to have to right click. Oops. This is what happens when you run in Visual Studio.
Everybody just got a glimpse of the RAS code.
Yeah. The real RAS code.
That's what's behind everything.
We have our inundation boundary map, but we have to right click and compute update stored map right after you add it, and that will give you this polygon. It's one polygon. So after you update it, you go down here to export layer, save inundation to 3D KML, and you get this little box that pops up. And a lot of it is auto-filled for you for max performance in Google Earth, as well as visual fidelity in Google Earth. But if you ever need to change things, here's what they mean and what they do. So the filter tolerance, this will filter the polygon, that's the inundation boundary, by so you get less points, and this will make the process go faster, but it'll be less accurate. The polygon cell size, so the way it works for Google Earth is we divide the polygon into cells, and this is the cell size for those cells. Larger cell size means less polygons, which means it goes faster, but it's less accurate. Lower cell size means more polygons, more accurate, but it takes longer. And the suggested size here is for to have around 10,000 polygons, which is like the limit in Google Earth. So this is like the trade-off between accuracy and speed. And then this is for output. If you want, you'll see later, you can query the Google Earth just like you can in RASMapper, and this is the decimal places for querying. And then the way the polygons work, you can either have a seamless look for your polygons with sloping water surface. So the polygons will actually slope. They'll actually have differing Z values at the corners or at every point.
Makes it look a little more 3D.
Yeah.
Mm.
And then the horizontal will just use the value at the center of the polygon or the cell, or yeah. And then if you ever, and then this plotting method, depths relative to ground, we use the depth in RASMapper to make the polygons. So if the terrain data is poor in Google Earth, then you'd want to use this. This will give you a more accurate representation. If the terrain data is fine in Google Earth, then you can probably just use the direct water surface elevation for your polygons. And then finally, if you want to keep the shape file, that's all the polygons that we send to Google Earth, you can keep it. So you can plot it as a layer or use it for something else if you want. So after you go through that dialog, you come to Google Earth, you go to projects, and then you start up new project, and then it'll give you an option to import a KMZ or KML file. So you just find where your file is, wherever you saved it, and you select it. And
so, and Anton, you're using, in this case, you're using the web version of Google Earth, yeah?
Yeah. For some reason, I can't get Google Earth Pro installed on my computer. I don't know why. So we're using the web version for now.
But the KML, KMZ will work in the desktop version as well. It's a little bit faster and looks a little bit nicer than the web version.
Okay.
Here we are in Google Earth. I imported my KML file, and we have water surfaces. You can zoom in, and you have to wait for Google Earth to update their meshes here. But once they're updated, you can click around. You can see the depth and the velocity and the water surface reported by RAS by just clicking anywhere.
That's really cool. Can you move around and do like an oblique view like you were doing in your 3D viewer too? And
yeah.
So in this case, if you wanted, if you didn't have the buildings part of your terrain but wanted to see them, you could do that here in Google Earth.
Yeah, a lot of terrains don't have buildings in them, so this is one way for now to see the buildings. So one of the more interesting views in Google Earth is how it works with real bridges. So you can actually see try and change the view here.
Oh yeah.
You can see the water is going under the bridge.
Right.
Now let me find some place where there's like some flooding going on so we can see the extent of the flood.
You can see all the buses there in the parking lot. There's the bowling center, Cam.
Yeah, I see that.
We were talking about.
GSR.
So
Grand Sierra Resort.
You can kind of see.
Oh, okay. Wow, look at that. You can see the cars flooded.
The depth where RAS is reporting like 2 feet. So that's about right.
Yeah. Wow.
I wanted to show in Street View how it looks like. These polygons in Google Earth Pro, they will show up in Street View. So you can actually see water over you or under you. But in on the web version, it doesn't show that, unfortunately. And
so if you had Google Earth Pro here, you'd see the water surface.
Yeah, you see the water right here where the cars are.
Oh, nice.
So yeah, it's too bad. Can't really show that here right now.
Yeah, we trust you.
Yeah, I mean,
everybody
that's
go
pretty
try
cool
that.
right there. So
Yeah, definitely.
So it's kind of slow. It's probably because it's the web version, but you see it works. Yeah, that's pretty much it.
Wow, that's really nice. Anton, man, that's really cool. Cool stuff. I think everybody watching here is super excited to try this out if they haven't already. What do you think, Ben? Any comments about this? You ready to try it out?
heck yeah. I think it's just the viewing experience overall, I think is just such a massive upgrade to this new version. It's really going to make not only it kind of more fun for hydraulic modelers to look over the results of their model, but it's just going to make client interaction so much better and presentation of data, especially to non-engineers. It's a huge step. So thanks for showing us that stuff, Anton.
No problem.
Everybody's going to be able to impress their clients with that.
Yeah.
Make them really happy. Yeah, very cool.
It doesn't matter how good the work is that we engineers and modelers do. If we can't share it with other people, then it's really all for naught. So I think the visualization of those results is really a key aspect to the engineering and analysis portion.
Yeah, it's a very powerful way to understand what's happening. I mean, gone are the days when you'd have to look at, a profile plot, and that's what you had, maybe a stage and flow hydrograph, and you had to try to explain to your client what's happening with those two features. We may know what's going on, but it's hard to explain that. But this is great. I mean, you can clearly see the result of that flood at a very close-up view, different angles and everything. So well done, Anton.
Thanks.
And Cam, great job on all the new RASMapper features. All super exciting stuff. Ben, you have any other parting words for these two geniuses here?
No, just want to thank you guys both again for coming on. Want to reiterate to everybody who's followed along here that there's a lot more information to learn. And so utilize some of those reference manuals that Cam showed us where to access those. And, there's a lot of other good videos, including some other videos on our YouTube channel that Craig Price has done. Check those out as well. There's going to be just a lot to learn here, and we're all going to learn together. And it's going to be really cool to see kind of what people do with this new technology. So thank you guys.
Yeah, and speaking of learning together, Ben, what do we got coming up for our HEC-RAS classes?
Yeah, so our spring 2021, or I guess winter 2021 HEC-RAS class, a 1D, 2D modeling class starts tomorrow, actually. And that particular class is full. We got 60 folks signed up for that, so that's really exciting. Wow. We're going to cover some of the new 6.0 features, including a new workshop that Chris developed around 2D bridges. So that's going to be really, really cool. We're excited to share that with folks from around the country. And if you're interested in taking a class, again, that class is full, but we're going to have another class sometime in May. So keep an eye out, ear to the ground for an announcement for exact dates on that. We expect that class to fill up just like this one. So you're going to need to sign up early if you want to.
I think this vodcast is going to be material for that class. When we get to the RASMapper part, we'll just say, hey, go home and watch Cam and Anton show you all the cool stuff.
Yeah.
You guys make our life easy.
Sounds like we're getting royalties, Anton.
Yep. There you go.
Is there any other plugs you want to talk about, Chris?
Yeah, I just want to quickly mention I've got a new HEC-RAS 1D steady class starting up the next week. In fact, next Friday, not this Friday. What is the date of that? So today's the 16th as we're recording it. So it would be the week after.
Friday's the 26th.
26th. Thank you. I should have wrote that down here. So it's not too late to sign up for that if you're interested. It's through the University of Wisconsin. I would just Google University of Wisconsin HEC-RAS. That is a basic 1D steady class. This is as basic as it gets. If you've never even heard of HEC-RAS, you can take this class and learn how to do some steady flow modeling with that. I've also got a couple presentations coming up. I'm doing one on probabilistic approaches to dam breach modeling using McBreach, and that's going to be through the Ontario Water Power Association. It's on March 4th. Go to owa.ca if you want to learn more about attending that. And then on March 18th, I'm doing a presentation on the Missoula floods, 2D modeling. And boy, I can't wait, Anton, to get this 3D viewer for my Missoula floods model. Maybe I'll try and get that going before the March 18th presentation. But that's going to be through the Seattle, Washington chapter of EWRI. So just Google that and you'll be able to see about that. And I think that's all I got for plugs, Ben.
That's all I got. I think, obviously, as you guys have heard, Chris is going to be all over the place this spring. So tune in to his LinkedIn page for additional announcements when it comes to where to find Chris.
Yeah,
you're like where's Waldo with HEC-RAS.
Not this year so much, but yeah, maybe again this year coming up, I'll be all over. But
Someday soon.
Cool.
Someday soon, yeah. We can go down there to Davis and get me some Pliny the Younger.
Better hurry. Better hurry.
Yeah.
It's only 6 feet away from me, so not gonna last long.
Oh man.
Awesome. Well,
Cool.
thanks again, both Anton and Cameron. Really appreciate you guys taking the time today. I know everybody who enjoys the podcast is going to enjoy the tools that you guys talked about today. Hopefully learn something from them. So yeah, again, it's been a pleasure, guys. Thanks.
Yeah.
And yeah, until next time, this has been Full Momentum and HEC-RAS podcast.
Thanks for having us, guys.